Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. Integration, lecture 8. Work done by Miss Bisma Sami of class 2021, the Lyceum. An important advice for me and for everyone: think before you speak. Another important advice: be of benefit to others. Here is the list of important questions of this book. This book contains questions from November 2009 to June 2016. Question number 1. The diagram shows the curve y is equal to ln x over under root x and its maximum point M. The curve cuts the x-axis at the point A. State the coordinates of A. The coordinates of A will be x comma 0 because A is on x-axis. Therefore, by equating y to 0 into this equation, we can get the x coordinate of A. So the coordinates of A are 1 comma 0. Find the exact value of the x coordinate of M. Since M is the maximum point, therefore gradient at M must be 0. So by equating dy upon dx to 0 here, we can easily get the x coordinate of M. A lot of algebra, a lot of calculation is required. Make sure you practice a lot so that you can easily handle these calculations. Therefore, the x coordinate of M is e power 2. Part 3. Using integration by parts, show that the area of the shaded region bounded by the curve and the x-axis is this. So by integrating this curve from limits 1 to 4, we can get this thing. Here is the integration. The area formula is, this is the area formula. Make sure you remember this formula. Lower limit, upper limit, y dx. So basically we use this formula here. Since this is by part situation, we always use by parts to integrate ln, and this function is product, so we have to use by parts. So according to late board, u will be ln x and dv will be x power minus half times dx. So this is dv and this is u. You know, we always differentiate u to get du, and we always integrate dv to get v. This is v. By substituting all like u, du and v, we can easily get the area. So u is here, v is here, this is v, this is du, and you know, this is, we just need to apply limits here, and we need to simplify this first and then we can integrate this. Again, a lot of algebra is involved in calculation. So this is the final answer, 8 ln 2 minus 4. In by parts, make sure you select u correctly. If you select u correctly, then you can easily handle the by parts. So in this question, u is ln x and dv is x power minus half times dx. And you know this, we always differentiate u because we need du here, and we always integrate dv because we need v. This is the substitution question. I use the substitution x is equal to 2 sine theta to show that You all know while substitution, we substitute the function. Here is the function. Then we substitute the operator dx. By differentiating the given function, we can get the integral operator dx. Make sure you always differentiate the given substitution to get dx. And then we change the limits. This is the upper limit, 1. So when x was 1, then theta is pi by 4. When x was 0, then theta is 0. Make sure you do calculus in radian mode. Now this is the question. Always copy the question and then go for the substitution. So when x is 2, then theta is pi by 4. When x is 0, then theta is 0. Copy this 8 here, substitute dx here, and substitute x square here. Now simplify this denominator carefully. This will become 16 and 1 plus tan square theta whole square. Let me do the calculation here. This calculation. Let me check if I have done this. Okay, let me do this calculation here. 4 1 plus tan square theta whole square. So this will become 16 1 plus tan square theta. This step is here. You know 1 plus tan square theta, I'm sorry, 1 plus tan square theta is sec square theta. 16 and 16 will be cancelled. This will become sec square theta. So finally this will become sec power 4 theta. So when you will cancel sec power 4 theta with this sec square theta, you will get 1 upon sec square theta. And finally you will get cos square theta. This is what we had to show. Next question. The next part. We have to integrate this. Obviously, we will use this thing to integrate this thing because it's mentioned, hence find the exact value of this integral. So you need to integrate this part. And you know, we can integrate cos square theta by using this formula. This is the double angle formula for cos square theta. And we always use double angle to integrate cos square theta and sin square theta. This is cos square theta. So here is the double angle formula. And by breaking the LCM, we have this. We can also bring this to outside the integral. So you have choice. Either you bring this to here, write this here, or break the LCM. So it's your choice. Well, by breaking the LCM, we have got this cos 2 theta upon 2 and half. So by integrating this cos 2 theta, we will get sin 2 theta upon 2, and that 2 will multiply with this 2, and we will get 4 here. And this will become theta upon 2. By applying the limits, we can get the answer. Sorry. Here we have to use by parts twice, because when the function of u has power 2, then we use by parts twice, because we use by parts, normally we use by parts to eliminate the product. So see here x power is 2. So when you will use by parts at the first time, then you will get x here. I mean, this 2 power 2 will be reduced into power 1. But we have to eliminate the product. So in order to eliminate this product, again we have to use by parts here. So whenever the function u has power 2, always use by parts twice. Well, this is u x square, so by differentiating u we can easily get du, and this will be dv. I mean, after the selection of u, the remaining function with the integral operator will be dv, or everything except u will be dv, except the sign of integral. So this is dv, sin x dx, it's here. By integrating dv, we can get the v, value of v, it's minus cos x. This is the by parts formula. Make sure you substitute everything carefully. Here we apply the limits, and here we just need to simplify this, and then we have to use by parts again over here. So by using by parts here, we can get this thing, because u is 2x, du is 2 dx, and dv is cos x, therefore v will be sin x. This is the by parts formula. Substitute everything carefully. This is uv part and this is v du part. The integral of sine is negative cos. By applying the limits, we will get minus 4, and by substituting this answer into equation 1, we can get the final answer, which is pi square minus 4, and this is what we had to show, I guess. Yeah. I'm sorry. Question number 5. Prove the identity. So whenever we have odd angle, we always use sum of angle to prove the identity. So cos 3 theta can be written as cos bracket 2 theta plus theta. And by using sum of angle formula of cos, we can get this thing. Since we need our answer in the form of cos, therefore we need to replace this sine 2 theta first, by 2 sine theta cos theta, and then this sine square theta. This is very important. Since we need our answer in the form of cos, therefore we must have to remove this sine square theta, or replace this sine square theta by cos square theta by using the identity 1 minus cos square theta. So make sure you prove the identity while observing the answer. Here is the final answer. And now, since it's mentioned using this result, therefore you need to you need to use this result to integrate this part. You cannot use any other method here, because it's mentioned using this result. What if we had using this result or otherwise? Then you can do anything, either use this result or do other method. But here, make sure you will use this result to integrate this thing. Well, to integrate cos cube theta, you need to make cos cube theta subject from this identity. So by making cos cube theta subject, we'll get this thing, cos 3 theta upon 4, 3 cos theta upon 4. Now you need to substitute this over here. It's here. Now it's very simple. The integral of cos is sine. Cos 3 theta is sine 3 theta upon 3, and cos theta is sine theta. Just apply the limits and this question will be over. Substitution question. I'm leaving this question because I already have done one substitution question. This is a question which is similar to question number 1. I'm leaving this question as well. Here you have to use the first part. Okay, let me discuss this question 8. Find the exact value of f prime 1 upon 9 times pi. So the part 1 is differentiation. You all know how to differentiate the composite function. We always differentiate composite function according to this rule. D upon dx ax plus b whole power n. So this will become n ax plus b n minus 1 times a. This is the rule to differentiate the composite algebraic functions. Sorry. Well, so according to this rule, this power will become coefficient, and then you need to bring this power. This power will become coefficient, so this will become 8, and subtract this power by 1, so this will become 1, and then you need to differentiate this bracket. So it will be minus 3 sine 3x. And then just substitute pi by 9 and you'll get your answer. The second part is of double angle formula. You all know to integrate cos square, we use this double angle formula. Since the angle is 3, so this angle will be double, 6. So here is the formula. You just need to simplify this first, cancel these two things. This is the simplified form, and the integral of cos is sine, and the integral of 2 is 2x. Since we don't have limits, therefore write c here. This is the partial fraction question. First you need to, the use of partial fraction in integration basically. So this is the required partial fraction. You all know how to get the values of a and b. First get the factors from this bracket and then this bracket. So there are two values of x. By substituting these two values one by one into this equation, we can easily get the values of a and b. So a is 4 and b is -1. By substituting a and b over here, we have got the required partial fraction. Sorry. Now just by taking sign of integral on both sides onto this equation, we can get this thing. Now this is the application of basic formula number 2. So the integration of this is ln 2x plus 1 over 2. Make sure you use modulus here. So whenever you write ln, always use modulus, because ln is always defined for positive values. Now just substitute limits, apply limits, and then use product and quotient laws here. You can get this answer. By using the product and quotient laws here, you will get this answer. Let me show you the answer again. So this is the partial fraction, and then the use of basic formula number 2 here, and then apply the limits, and then you can get the answer by using product and quotient laws here. So, another substitution question. So by using this substitution to show this, well, substitution is given. You just need to differentiate the given substitution to get the value of dt. Here we have to substitute dt to get this thing. So this is the value of dt. By substituting this, we have got dt. And these are the limits. When the value of t is 2, then x is 5. When the value of t is 0, then x is 1. I have made t square subject as well, in case we have to substitute t square. So now substitute the things carefully. This is very important. At the first step, we are unable to substitute for t cubes. Just copy 4t cube here. If you are unable to substitute anything at the first step, just copy that thing as it is, because after the cancellation you can easily substitute that thing. So 4t cube, copy here. You should copy 4t cube, and then you need to substitute t square plus 1 by x. This is here. In fact, here the student substituted t square. it's fine. And then substitute dt by dx upon 2t here. See, we can cancel these two things, and then we'll get 2t square, and we know the value of t square. This is t square. So here is the final answer. So the rule is, don't try to substitute everything in at the first step if something is not substituting easily. So you can substitute that thing easily in the later part, like later on. Like here, we cancel these two things and then we substitute it. And finally, we have got our answer. Now this is the by parts. I'm not discussing by parts. You all know how to handle this. I'm just going to show you the solution. Here is the solution. You just need to handle the things carefully. Substitute everything correctly into by parts formula, then get the simplified form of this, then integrate this. By applying limits, you can easily get the answer. You should be good at algebra if you want to handle these things easily. This is one of the most important questions of this book, especially the third part. Well, part 1 is show that the area of shaded region is this. So this is very simple. You just need to use by parts twice. See, since the power of the function of u is 2, therefore use by parts twice. Because of this 2, you need to use by parts twice. Because when you will use by part at the first time, you will get this x square as x here. This x square will become x at the first time when you will use by parts. And since we use by parts to eliminate the product, therefore we have to use by parts again here. Well, this is the first time we are using by parts. U is x square, therefore du is 2x dx. This entire is dv. By integrating dv, we will get v. You all know how to integrate e power minus x. The integral of e minus x is e minus x upon minus 1. Finally, you will get minus e minus x. Use by parts here. So by using by parts here, we'll get this thing. By substituting this result into this equation over here, we can get the answer. 2 minus 17 upon e cube. I'm showing you the calculation here. Here is the by parts formula. Part 2, find the x coordinate of the maximum point M on the curve. For that, you just need to find the gradient and then equate gradient to 0. Here is the calculation of part 2. This is UV rule. So UV prime, VU prime. This is the x coordinate of M. Now part 3 is very important. I'm discussing this question just for this part 3. Sorry. Find the x coordinate of the point P at which the tangent to the curve passes through the origin. Now here is the tangent at P which passes through origin. So there are 2 points on this tangent. One is 0, 0 and the other one is x comma y, and y is equation of the curve. So when we have 2 points on any line, then we can easily get the gradient of that line. So here are the 2 points on the tangent. So by using these 2 points into this formula, we can get the gradient of the tangent. And you know gradient of the tangent is dy upon dx. And we have the expression of dy upon dx. It's here. This is the expression of dy upon dx. So by solving this equation, we can get the value of x. So the important part of this question is this point. Make sure you get this point uh, from this tangent. Like substitute y by equation of the curve. Miss Bisma had used the same thing here, but she used this thing in a different way. She substituted y here, in fact later on. She used these 2 points. She did not substitute y here, like I substituted y here, and then she got this thing. This is basically she used m here and dy upon dx here. And finally she substituted y by the equation of the curve here. So it's fine. So you have choice, either use this method or this method. Both methods are right. I initially substituted y here and she substituted y here later on. So it's your choice. You can use any method. Both methods are fine. By parts question, I'm leaving this question because this is simple. You just need to, I'm just going to show you the calculations. This is u and the rest is dv. This entire is dv, e power minus half x times dx. You all know we always differentiate u to get du, and then we always integrate dv to get v. Then substitute everything carefully in by parts formula, and by integrating this thing and by applying the limits we can get the answer. So it's very simple. Okay, this is an important question because of the calculations. So first part is we need the x coordinate of m. You all know m is the maximum point, therefore gradient at m must be 0. So by using UV rule here, we can get this answer. This is UV rule, UV prime, VU prime. So by solving this entire thing, you can easily get the answer. Again, a lot of calculation is involved. I mean, you must be good at algebra. You need to practice a lot to handle these calculations easily. Now the second part is use the substitution, find the area of the shaded region. The substitution will always be given in P3, therefore you don't need to suppose anything. I'm sorry. This is u. By differentiating u, you can get du or dx. Dx. So this is dx. So limits 1 and 0. Like when x is 0, then u is 1. When x is pi by 2, then u is 0. This is the area formula. Y dx. Again, the substitution is important, and this is very important. When the lower limit is greater than the upper limit, then you always change the limits by writing negative sign before the sign of integral. Since 1 is here and 0 is here, therefore you need to change the limits by writing minus here. Well, here is the substitution. Cos square x is u square. Let me write this step here. The substitution one. This one. This is basically (1, 0, 5, sine cube x, and this cos square x will become u square, and dx is minus du upon sine x. See, we couldn't substitute sine cube x here, so no problem. We can substitute this in a later part, in later on, in fact. So by cancelling this sine x with this sine, we'll get 5 times sine square x times u square. We will get this thing after the cancellation and changing the limits. We'll get 5 sine square x u square du minus sine. This minus is here. Now this sine square can be written as 1 minus cos square x, because substitution is given in the form of sine, cos. And then this 1 minus cos square x will become 1 minus u square times u square. So make sure you substitute everything carefully. And now get the simplified form. This is the simplified form of the integral. Let me check this minus sign. This minus should be plus. Wait a minute, let me check the negative sign. We had minus sign here as well. Here. So we have this should be plus. Wait a minute. Yeah, this should be plus. And this is also plus. Five u cube over 3, it's fine. 5 u power 5 over 5 is fine. Now let me check the answer. It's 5 upon 3. 5 upon 3 minus 1. 5 upon 3 minus 1 will become 2 upon 3. Yeah, this is fine. The answer is 2 upon 3. Now let me show you the calculation again. Here is the calculation. Do the substitution carefully. This is very important. Get the simplified form. This is the simplified form. In fact, this is the simplified form. And then integrate this form and then apply the limits, and then you will get the answer. This is the by parts question. I'm leaving this question. This question is important. The first part is of substitution. It's given u is tan x. So dx will be du upon u square plus 1. Because the differential of tan is sec square, and sec square can be written as tan square x plus 1, and tan square is u square. So make sure you get the, wait a minute, you get the form of dx correctly. You should get the correct form of dx. This is the most simplified form of dx. Now change the limits. When when x was pi by 4, then u is 1. When x is 0, then u is 0. These are the limits. Sorry. Now substitute everything correctly and carefully. See, this is tan power n plus 2. So this will become, after the substitution, this will become u power n plus 2. This will become u power n. And dx is du upon u square plus 1. So here is the substitution. Now you just need to break this un plus 2 as, by using the rules of indices, you can simplify this as u power n times u square, because you have to take u power n common from these two terms. And then you just need to cancel these two. Finally, we have u power n, and then this is the final answer. I'm going to show you the calculation again. Here is the calculation. Sorry. Now second part. Now second part is very important, especially 2 part B, because we have to use this structure. If you observe this structure carefully, you will see that the difference in power is 2. This is n plus 2 and this is n. For example, this power is 5, so this must be 3. And the lower power is here. N is here. Let me explain you this with this part. Number one, since it's mentioned that use the result of the first part, so we need to convert, we need to bring this integral in the form of in this form, in the form of tan. First, bring this integral in the form of tan. So by taking sec square x common, we have sec square x minus 1. You know sec square x is tan square x plus 1. And sec square x minus 1 is tan square x. Now this result is very important. This is of the form of this integral, this one. And the power difference is 2. So after getting this integral, observe n. This is n. And then use this result. 1 upon n plus 1, and n is 2, so this will become 1 upon 2 plus 1, which is 1 upon 3. Here is the answer. Since n is 2, therefore write 2 here. So the first important thing is get the standard form, get the form of tan. You just need to bring this integral in the form of tan first, and then use the result of part 1, this result. And make sure the coefficients are also 1. If you observe the coefficients of tan here, the coefficient of this tan is 1 and the coefficient of this tan is 1. So coefficients must be 1, because in the standard result the coefficients of both the tans are 1. This is 1 and this is 1. Now part 2 is very important. Here we need to get this form. The problem is with coefficients. This coefficient is 5, this coefficient is 5. So we need to write these two functions as, these two functions should be of this form. in order to use the result of part 1. I mean, we must have same coefficients. So when we will write 5 10 to the power 7x as 1 10 7x, then you know this is 5, so 4 10 to the power 7x will be left. Basically I wrote 5 10 7x as 1 10 7x and 4 10 7x. I broke this 5 into 1 and 4 because I need 1 times 10 power 7x with 10 power 9x. I hope you all have understood this. So here, see this. Number 1, I'm sorry, I wrote 5 10 power 7x as 4 10 power 7x and 10 power 7x here. And I did the same thing with this 5 10 power 5x. I wrote this as 4 10 to the power 5x, and then 1 is here. 1 10 power 5x is here. This x is here, not here. And 10 cube. Let me solve this question here. Let me do this step here. Part B, 0 pi by 4, copy 10 power 9x. Now this is important, 5 10 to the power 7x. This term should be written in this form, 10 power 7x 4 10 power 7x, so that we can get these two with same coefficients. Now write this 5 10 power 5x as 4 times 10 power 5x plus 1 times 10 power 5x, because the coefficient of this 10 is 4, therefore we must have 4 here. That is why I broke 5 10 power 5x as 4 10 power 5x and 1 10 power 5x. And then copy the last term, which is 10 power cube x. Now if you will observe these two, sorry, here n is 7, here n is 5 because n is the lower power from these two, and here n is 3. Now you just need to use these results here. The result was 1 upon n plus 1, like 7 plus 1. Take 4 common from these two and write 1 upon 5 plus 1, and then write 1 upon 3 plus 1 here. Finally you will get 25 over 24. So in this question, coefficient, in part B, the coefficients of 10 are very important, and we made the coefficients same by breaking 5 10 power 7x at first, and then 5 10 power 5x at the second time, and then after that we broke these two in a proper way, in a way so that we could get these coefficients 1 and same coefficients here, and then same coefficients here. So the breaking of the coefficients are very important in this part B, part B. This question is over. This is a simple question. You can easily handle this. Substitution question, and then you have to use partial fraction here. Let me discuss this question 17. This substitution is given, and you just need to first differentiate the given substitution here and get this dx. So we will use this u and then this dx, and here are the limits. See, when you will substitute the things here, make sure you do the substitution carefully. You just need to copy 5. This 5 is here. Limits 2 and 1. Because when x was 2, then u is 2. When x was 5, then u is 1. And in the denominator, you just need to copy this x here, and this under root will be substituted by u, and this is dx. This is multiplying. Now you need to substitute, basically you substituted x here. Here is the x. So by breaking the middle term here, you can easily get the answer. And make sure you switch the limits as well, because lower limit is greater than the upper limit. So by writing negative sign before the sign of integral, you can switch the limits. And this is the integral I. So here is the final answer, partial fraction. Use partial fraction to integrate this, and you know how to handle these calculations. We already have discussed a question of this type before. Make sure when you integrate this part, you integrate this part carefully. Like the integral of this is 6 times ln modulus 3 minus u upon minus 1. And that minus will come here. This is also in modulus. Always write modulus with ln. And here is the final answer, 2 ln 9 upon 2. Here is the calculations. By parts question, I'm leaving this. The second part is important, volume. So let me discuss this question. First part, we need equation of the tangent at where x is 1. So number 1, by using UV rule, we can get the gradient, and the gradient of this tangent at 1 is 1. And by substituting this 1 over here, we can get the y coordinate, which is 0. And here is the equation of tangent. Now second part is we need volume of the shaded region. First we need to get this number. This is 1 because the y coordinate of this point is 0. And this is the formula of volume of rotation. You already have done this formula in your A1. So by using this formula correctly, you can easily integrate this, but make sure you integrate, you should know that you have to use by parts twice because of this power 2. Since u has power 2, the function of u has power 2, therefore use by parts twice. So by first differentiating this u, by using by parts at the first time, we'll get this thing. This is the composite function. It will become 2 ln x upon x. Let me show you the differentiation of ln x square here. By using composite differentiation of the composite function rule, this will become 2 ln x 1 upon x. This is the way to differentiate ln x square, ln x whole square. Make sure you won't use power law here, because ln x whole square is never equal to 2 ln x. So don't use power law over here. I'm sorry. So this is u, and this is du, and this is v. Now substitute everything correctly into this by parts formula. So you will get this thing. By substituting everything correctly and carefully, we'll get this. Apply limits onto this part, get the simplified form of this. See, again we have ln, and to integrate ln we use by parts. That is why we use by parts twice in this question, in these type of questions. So by using by parts here, we have u ln x du dx upon x, and v is x square upon 2. By applying limits, we'll get this thing. Now substitute this thing here. Put this result into equation 1. This is the equation 1. By substituting everything carefully into this equation, we can get this answer. Make sure you should be good at algebra if you want to handle these calculations easily. A lot of calculations are involved in these type of questions. Here is the solution. It's not easy to use by parts twice in Cambridge exam. If you practice a lot, if you practice more, then you can handle these type of questions in 7 or 8 minutes. You have to complete this part within 10 minutes. Another important question. By differentiating 1 upon cos x, show that if y is sec x, then dy upon dx is this. Very important question as far as calculations are concerned, steps are concerned. So d upon dx 1 upon cos x. You know, we can write this 1 upon cos x as cos power minus x. And during the simplification, you all know we copy d upon dx. Make sure you copy d upon dx here. Now, by using the differentiation rule of the composite function, we can easily differentiate this. Minus 1 will become coefficient. It's here. Let me write minus 1 here. It's fine if you just write minus, but to make it simple, I'm writing minus 1 here. Power will become minus 2, and the differential of cos is minus sin x. Sin x upon cos square x. Now you can simplify this. I mean, you can write this as, you should simplify this here. Sin x upon cos x twice. Now sin upon cos will become cosec. Will become tan. And this 1 upon cos will become sec. Now let me solve the next part. If y is equal to sec x, you know, this left side can be written as d upon dx sec x. 1 upon cos can be written as sec x. So the result, the differential of sec is tan x sec x. 1 upon cos can be written as like sec x, and the differential of this sec is tan x sec x. So as we know, the differential of sec is sec x tan x. Therefore, dy upon dx is sec x tan x. Let me do this calculation again. It's page number. This is the page, right? Let me add one page here. I'm going to solve this question, this part 1 here. So by differentiating 1 upon cos x, you all know how to differentiate 1 upon cos x. So this can be written as cos minus 1. We already have discussed how to differentiate this. I'm sorry. So this will become sin x upon cos x twice. So this will become minus tan x sec x. And this left side will become sec x. This is part 1. Now you know it's given y is equal to sec x. Therefore, with the help of this result, we can say the differential of sec is sec x tan x. This is what we had to show. This is positive sign, this is positive, and here is the result. We had to show this thing. This is what I wanted to explain here. All right, the next part is, let me show you the calculations again. This is the calculations of part 1. Normally students are weak at this calculation. They don't handle these calculations carefully. That is why I did this calculation again. And let me erase the previous calculation, this one, so that this will not be complicated. This is the method of Miss Bisma. So I'm just leaving her method as it is. Her method is perfectly fine. And this is my method. You have both the options, you can use any method. Part 2 is simple. You just need to rationalize whenever we have different signs and same expression. So we always get the answer by rationalizing this left side. You just need to rationalize this left side. So by rationalizing the left side, we have got this result. I'm sorry. Last part, part 3. Deduce this. This is very simple. See, part 2 and part 3 both are interlinked. In part 2, the power of this thing, if you observe the power of the function here, it's 1 and here is 1, right? So when we have power 2 here, then this power will be 2. So we just need to utilize this result with power 2. So by squaring on to this result, we can get this answer. And this is what we had to show. Now the last part, we just need to integrate this. Obviously we will not integrate this, we will integrate this result. So by substituting this entire thing with this result, we have this. We all know the integral of sec square. The integral of sec square is tan, and the integral of sec tan. Now this is very important. How to integrate this product? For that you have done this part. See, this is the differentiation, and the opposite is of integration. So the integral of sec and tan will be sec x. That is why we had sec x here. From part 1. And then you just need to apply the limits. I'm going to show you the calculations again. Part 1, there are 2 ways. This is my student's way, and this is my way. You have option, you can use any one. Part 2, just do the rationalization. Part 3, just square the answer of part 2. Get the answer 2 sec square x minus 1 plus 2 sec x tan x, this thing. And then utilize this result, the answer of part 3 over here, and then answer of part 1 over here. This question is very important. This question is very simple. The last part is important, and we need, this is the shaded area. Use the substitution, get the shaded area. This is very simple. You just you know how to do the substitution. I'm not discussing the part 1, I'm just going to discuss part 2. Now this is very important, part 2. See, when you this limit is pi by 4, it's here, See, when you integrate this function from 0 to pi by 4, you get this answer, 1 upon 24. This is the answer when you integrate 0 to pi by 4. So what would be the answer when you will integrate the same function for this limit k pi? It's mentioned 40a. See, everything is same, and when almost both things are same, just one thing is different, limit, then it's a comparison question. Like when both the integrals are similar, that means the question is you can say comparison question. So it's a comparison question. See, when the limits are 0 to pi by 4, then the answer is a. So when the limits are 0 and k pi, then the answer is 40a. So it's a comparison question. So you just need to write this thing here. When limits are pi by 4, the answer is a. When the limits are 0 to pi by 4, answer is a. When the limits are 0 to k pi, then answer is 40a. You just need to use ratio method. You can use ratio method with a's, and you can use ratio method with the answers. Then k is 10. I use the ratio method with respect to a, and here the ratio method was used with respect to the answers, with respect to the values of a. So in comparison question, make sure you use ratio method. This is the repetition of question. This question, I think it was question 19, I guess. Yeah, question 19. So that question is the repetition of question 19. This question is fine. Now this is very important. No, this question is simple. This is by parts. Now this question is very important. This is the integration without limits. So whenever you have this question, substitution without limits, substitution for indefinite integrals, then the most important thing is you must substitute the function by the original variable. U must be substituted by the original variable. This is very important. Don't leave your answer here. Substitute, rewrite the function in the original variable form. U must be substituted by 3x plus 1 over here and over here. So when we have questions of substitution for indefinite integrals, then we always rewrite the function in the form of original variable. This thing and this thing. This substitution is given by by differentiating this substitution, we can get the value of dx, and then by substituting u and dx here, we can get this form. Make sure you use bracket here. The integral of 1 upon 3 is u upon 3, and the integral of minus 1 upon 3 u. Now this is very important. Don't integrate the coefficient, just integrate the function. You can write this as minus 1 upon 3 u can be written in this form. So minus 1 upon 3 ln u. This is u. Don't do this way. This will make the calculation very complicated. This is not the right way. So always write the function without the coefficient. And finally, rewrite the question in the original variable form. Substitute u by 3x plus 1. Well, this is all from this lecture. I hope this lecture would help you a lot to understand the concepts of integration. Let me finish this lecture here. So be good to everyone. This is the advice for me and for everyone. Allah Hafiz.